Okay, we're going to talk about how to find the volume of this composite figure. Okay, so our first step is 1, cut the figure. Okay, that means a composite figure is a figure that's made up of 2 separate shapes. So this is not a common shape. Okay, it's a 3D figure, but it's not a common shape. But if I were to cut it, say right across here, I can see a rectangle here and a rectangle here. Or I can cut it here, okay, here, and I have a rectangle here and a rectangle here. Either way you cut it, you are going to get the same answer. Okay, for the sake of this demonstration, I'm going to cut it right across. Okay, right across. Okay, so once I cut my figure, then I'm going to set up my formulas for 2. I have 2 figures, that means I need to have 2 formulas. Okay, so first thing, volume equals length times width times height. And for this formula, we'll call this figure figure 1 and this one figure 2. Okay, so this is for figure 1, and for figure 2, it's going to be volume equals length times width times height. Okay, all right, so now I have to find those values. I want you to remember length is side to side. Okay, so or left to right. Okay, so those are things like this dotted line here is your length because it goes side to side. Okay, width goes front to back. I'm going to put this kind of diagonal because that's how you see it shown in your picture. So I'm going to write front to back. Okay, so you see this dotted line. It's a 3D, so you have to use your imagination here, okay? So front, back. This is the front of the figure. This is the back of the figure. This dotted line is your width, okay? And then our height is up and down. So up to down, okay? So our height is like this dotted figure here. Down, up, down, okay? Measuring how tall something is. Okay, so now let's go look at our figures. We'll start with figure 1 and see what we can figure out. So I have volume equals length times width times height. Let's start with the length. So again, length, left to right. So I'm seeing it is anyone, I'm going to point out all the spots on this figure that show me length. Okay, this dotted line shows me length. This line across where I cut it, this all shows me length. And this line, if I see length back here, I can draw the rest of it over there. That's length. And then this back here is length. Now, if I look at any of those, I can see that this one gives me the full measurement for the length of that top figure. So I'm going to rewrite volume equals, and instead of writing L, I'm going to write 12, okay, times, because I got to fill in the rest. Okay, now width. Remember, width is front to back, front to back. Okay, so on this top figure, I'm looking at anything that gives me a width. Okay, this line is front to back. It could give me width. This line is front to back. It can give me width. This line is front to back. It can give me width. And then there's an imaginary line right here. Also, front to back. It can give me width. Okay, based on those, are there any that show a value for width? Yes, this one right here. See, it's right there next to it. So 4 for width times. Okay, now I gotta find the height. Based on this figure, we're looking for height. Now, the things that show me height, up to down. Okay, up and down. Okay, this one goes up and down. That could be my height. This one goes up and down. That could be my height. This one back here, up and down. That could be my height. And this one here, up and down, can be my height. Which one of those has a value next to it? Well, this one. Up, down, says 6. Okay, so 6. So now I have what I need to solve this. Well, let's solve it. Okay, So we have 12 times 4, so this is going to be just like order of operations, 12 times 4, which is 48. Okay, bring down what I have not used, including my v equals. Now I have 48 times 6. V equals 48 times 6. This is a great time to look at how our multiplication, if we forgot, 48 times 6. 8 times 6 is 48. 8 plus 4. 6 times 4 is 24, plus 4 is 28. So the volume for this one is 288 inches cubed, because we're looking for volume. But this is not my answer for the whole thing, okay? Because I have to find the volume of this figure here. So again, volume equals. Now I'm looking for the length. I'm looking that tells me a side-to-side length, okay? So here's side to side, back here is side to side. This would be side to side. Back there would be side to side. Which one of those has a length by it? Well, this one. Side to side, 5. Left to right side, there's 5. Okay, times. Now our width. Remember, our width is front to back. Front to back. Okay, let's look at all the things that have front to back. Front to back, front to back, front to back, front to back. Do any of those have measurements? No. But, big but, the width is the same. The width is the same because the figure is the same width, okay? It doesn't have different dimensions, okay? It's not like a cone where this is wider than this. It's not that, okay? This is like a book, okay? So this book is this wide on this side, but if I flip it over, it's this wide on this side. It's the same, okay? So when we're doing composite figures, the width is the same on both shapes, okay? So if I look up here and it showed me a width of 4, that means my width over here is also 4, because look, there's my width, and this side, I know from a rectangle, this side and this side are congruent. Well, if this side and this side are congruent, that means this side and this side are congruent. So that makes this 4 inches as well. Cool, got our width. Okay, now times, now we're looking for our height. What is going to show me how tall something is? Okay, I'm looking for how tall this is. All right, well, I don't have anything because I'm seeing up and down here, up and down here. Remember, height is up and down here, and up and down here, because I cut it right there. Okay, up and down. I know this whole thing here is 14. Okay, that whole thing is 14. I don't want the whole thing. I only want this part. Okay, the whole thing is 14. And I know this little part here is 6, which is congruent to this over here, which is 6. Okay, so I will subtract 14 and 6. Okay, 14 minus 6 is 8. Okay, so 8 is my height. We have to understand when we are finding a missing side, you're not going to use length, the two missing, a length side and a width side to find a length side. No, you have to use a length side and a length side to find a missing length side. Okay, that's like if I said I have one dog and you have one dog, and then I ask you, okay, well, how many cats do we have altogether? You would say, I have no clue, because you didn't talk about cats. Okay, so it's the same thing. So you have to do length minus length to get a length. Okay, because this, since we cut it, is made up of 2 parts. Here's a part, which I know is 6. Here's the total. So what plus 6 equals 14? Well, 8. Okay, so now I'm going to do my math. 5 times 4 is 20. Okay, bring down my times 8 and my v equals. Okay, and then I have v equals, now I'm going to do 20 times 8. We'll do it right here. 20 times 8. Okay? 8 times 0 is 0. 8 times 2 is 16. 160. 160 inches cubed. Again, not my final answer, because I want the volume of the whole thing. I found the volume of 1. I found the volume of 2. Now we're going to find the volume of the whole thing, 1 and 2. Okay, so I'm going to go right up here where I have room, and I'm going to take this volume and this volume, and I'm going to add them. 288 plus 160, okay, 8, 0, 8, I'm adding, okay, 8, 6, 14. 1 plus 2 is 3, plus 1 is 4, okay? It would be, so the volume of the entire thing is 448 inches cubed, okay? So if you followed along with me this whole time, your scratch paper should look just like this. You should have everything written down that I wrote down. Okay? All this stuff is important, especially this stuff and this stuff. Okay? First, cut the figure. Second, find volume of both. And then we'll squeeze in a third. Add volumes together. Okay, those are the 3 steps to finding the volume of a composite figure.